Alright, we already know how to minimize functions, but now let's try it looking at minimizing a function with constraints. This is also called the Lagrange Multipliers. And the example we will take a function xy that is x squared y, and the constraint will be x squared plus y squared equals 1. And we call this function g of xy. X squared plus y squared equal 1 is actually a circle. These are all circles, these contour lines are all circles. But let's draw the contour lines. Contour lines are lines where f of xy equals c, and c is a constant. Yeah? The same you have for this. But we took this circle with radius 1, and then where x squared y is a constant, these are lines like this. You start up and then you go down. Yeah? This is for one c. And you have many of these lines. Yeah? This is for another c. Yeah? So what we're gonna do, we're gonna choose c so that the contour lines kiss each other. Yeah? So that's basically, the c that draws this line. Yeah? Here you go. So this here is what we see in this area. We know the gradient is perpendicular to the contour line, so this is the gradient of f. But since they kiss, right, the gradient of g will be in the same direction, or either in opposite direction. Yeah? But the gradient of g will also be on this line. And we can put it here, gradient of g. Doesn't really matter where it is. So this we can write that the gradient of f in that specific point, let's call this x minimum, y minimum, equals the gradient of g in the same point, x minimum, y minimum, times a proportional constant, lambda. Yeah? So this is the equation that we need to solve. And as for an example, we can quickly do that. So the gradient of f is, we know a gradient is a vector. So first we derive for x, that is 2xy, and then we derive for y, that is x squared. The gradient of g equals, well, it's 2x and 2y. This is our vector. So that gives us a set of equations that 2xy equals lambda to x, and x squared equals lambda to y. Now, two equations. But we have three unknowns, so that's a problem. So we need to add an equation, and we're going to add the constraint. So x squared plus y squared equals 1. Yeah? And this we can easily solve, because this x goes away together with the 2, so we have already that y equals lambda. Yeah, we have immediately. So I can substitute this line by y, so then we have x squared equals 2y squared. Yeah? And what I'm going to do is now put the x squared in here. So the last equation, which I would call number 2, becomes 2y squared plus y squared, meaning 3y squared equals 1. Take the 3 out, is 1/3, and y equals plus or minus the root of 1/3. So now we have y, and y equals lambda. So now we need to find x. Yeah, so we can use the middle equation here. So let's call this number 3. So x squared equals 2, and y squared is 1/3. That means that x squared is 2/3. That means x equals plus or minus square root of 2/3. Okay, so we found x, y, and lambda. And that's how we will deal with minimization functions, or minimizing a function with constraints. Okay, let's now take a look at the Taylor series as the last item of this refresher.